Hello guys, so here we are to the third question of this bi-weekly contest 36. Let me thank to the guy that told me that I can use OBS Studio to screen record my PC. So this question was wasn't the hardest. Actually, I found it was easier than the previous question, and it is a DP problem. I don't immediately identify it as DP. I tried. I didn't try it, but I was exploring the solutions. But it ended up being a DP. And what is asked in here is to find a matrix that would fulfill the requirement of the sum of its rows and the sum of its columns respect the provided input row sum and column sum. Okay, so well, that's about it. And there are some constraints in here, like there non-negative integers. Okay, there is no negative integers, and there is always a solution. So this is the information that is relevant, and you can always check the constraints here in order for you to understand if your solution is good enough to avoid the time limit exceeded. So, sorry. So this is kind of the scenario, okay? We receive a row sum array and a column sum array. And this row sum as the sum that your generated matrix has to respect. For instance, in here we have the row 1 as a limit of 5. So the sum of all elements in this row need to be 5. And the same applies to the columns. Okay, the column sum, the first column is 8, so the sum of your generated matrix needs to be 8. Okay, so from my perspective, the difficulty of this problem was not to get to a possible solution. That wasn't the hardest part. The hardest part was indeed proving that my solution would cover all the cases, and that's what I was not able to confirm. However, I developed my solution and I was able of passing, but I was not able to prove it. So despite my solution worked and is aligned with many other guys that did a similar solution, I was not happy. So okay, we can now try to understand what is this solution about DP about. The approach that we are going to use to fulfill this matrix is based is greedy based. Okay, so I will put here a limit of 8, a limit of 6, a limit of 8, and here we will put a limit of 5, a limit of 7, and a limit of 10. So what we want here is we will take always the maximum value possible, you know, to fill a given a given cell. So When we get to this first cell, what values is possible? Is 6 possible? No, because if we put 6 here, it is bigger than the row limit. So despite the column limit is 8, we cannot go above 5, because if we do it, we break the requirement. So the minimum of these two values is the one that wins. So we will put 5 here. And we remove 5 from here. We decrease it by 5, so we get 0 for this column. Okay, this is the next iteration. So next, the next row is this one, and the minimum between the row and the column is 0. Okay, and why 0 is the only possibility? Because if we put any other number that is not 0 in here, we will break the requirement. So we can only put 0 in here, and the same applies to this cell. And the explanation is that otherwise we break the requirement. When we move to this cell, what are the possibilities? And I forgot to mention that when you decrease in here in the row, you also have to decrease in here in the column. So this is no longer 8. This is now 0. I'm sorry. This is 3. And it's easy to understand, right? Because if you could put 8 here again, you would break the 8 limit. So you can only put the maximum between 3 and the row value, which is 7. So you can put that maximum 3. If you put 4, you break the requirement, because this column could only take 3. And you continue this logic, okay? You continue this logic for the rest of the matrix. It is kind of a standard DP problem, and it is not very off the hook. Okay, it's easy to understand. So about the code is also very simple. Okay, very simple. We initialize our DP with the row and column size, and then we will traverse our matrix and get the minimum of both columns, and then we will subtract the row and column respectively and return our DP table. Is as simple as this. Okay, as simple as this, and this is how it went. Okay. Probably there are also better solutions, but this was what I was able to come up with, and hope you have enjoyed.